Now that we talked about observed and expected frequency, we're going to talk about the chi-square goodness of fit test. To perform a chi-square goodness of fit test, these conditions must be met. First of all, the observed frequency must be obtained using a random sample. Each expected frequency must be greater than or equal to 5. If these conditions are met, then sampling distribution for the test is approximated by a chi-square distribution with k-1 degrees of freedom, where k is the number of categories. The test statistic is chi-squared, which is the summation of observed frequencies minus the expected frequencies to the second power divided by E, which is the expected frequencies. When the observed frequencies closely match the expected frequencies, the difference between the observed frequencies and expected frequencies will be very small, and the chi-square test statistic will be close to 0 because this difference is going to be very small, so it's going to be close to 0. If this happens, the null hypothesis is unlikely to be rejected. However, when there are large discrepancies between the observed frequencies and the expected frequencies, if these two numbers are very different from each other, the differences between the observed frequencies and expected frequencies O and E will be large, resulting in a large chi-square test statistic. A large chi-square statistic is evidence for rejecting the null hypothesis. So this is a key here for you. And let's take a look at one example and the guidelines to follow. So first, verify that observed frequencies were obtained from a random sample and each expected frequency is at least 5. Identify the claim, state the null and alternative hypothesis, specify the level of significance, identify the degrees of freedom, which is k-1, determine the critical value. You can use your calculator or you can use online websites, determine the rejection region and find out chi-squared, which is the summation of observed value minus the expected value to the second divided by E. Make a decision about the null hypothesis. If chi-squared is in the rejection region, you're going to reject the null hypothesis. Otherwise, you're going to fail to reject the null hypothesis. Let's go back to the example that we introduced at the beginning of the class. A retail trade association claims that the tax preparation methods of adults are distributed as shown in the table at the left below. A tax preparation company randomly selects 300 adults and asks them how they prepared their taxes. The results are shown below here. So distribution of tax preparation methods: by accountant 24%, by hand 20%, computer software 35%, friend and family 6%, and tax preparation service 15%. We did the calculation in the very first example. And this is the survey result. So again, 61 divided by 300 is 24%. 42 divided by 300 is 20%, and so on. Now let's take a look at the steps. What's the null and alternative hypothesis? Null says the expected distribution of tax preparation method is 24% by accountant, 20% by hand, 35% by computer software, 6% by friend and family, and 15% by tax preparation service. This is the claim. Remember that you identify the claim from the question. Here you have the keyword claim. So this is your null hypothesis. It is. The alternative is not. The distribution of tax preparation methods differ from the expected distribution. So now that we identify the null and alternative hypothesis, we're going to identify alpha. Alpha is given in the question as 1%. The degrees of freedom is k-1. Remember that k is the number of categories. We have 1 category, 2, 3, 4, 5 categories. So degrees of freedom is 4. Very good. It means that the critical value is going to be 13.277. Now, we need to calculate the chi-square test statistic using the formula, the summation of observed minus expected frequencies to the second power divided by the expected frequencies. So the very first one is 61. 61 minus 72. Again, guys, remember that we did the computation in the first example. Use the first example to check these numbers. So observed is 61, expected is 72. Raised to the second power divided by 72 is for first category, plus observed minus expected to the second power divided by 60 for the second category, and so on. We add these numbers together and we see that it is 16.958. All right. This number, the chi-squared test statistic, is 16.958. And remember that this is the distribution that you have, and this little part is the rejection region. In summary, by looking at the figure on the left-hand side, you can see the location of rejection region and the chi-square test statistics. Since chi-squared is in the rejection region, you're going to reject the null hypothesis. There is enough evidence at 1% level of significance to reject the claim that the distribution of tax preparation methods and the association expected distribution are the same. Now let me show you how to use your calculator. And let me see. Let me share the screen. You can see the calculator as well. There we go. Here we go. You need to enter the data that you have in L1 and L2. So you can go to Stat, you can go to Edit, and enter the observed and expected values in L1 and L2. Very good. Now go to Stat, go to the tests, and then find the chi-squared goodness of fit. The observed are in L1, expected in our L2, and the degrees of freedom is 5 with a calculation. And as you can see, your chi-squared is equal to 16.958. And this is exactly the same as what we did for the calculation. The p-value is going to be 0.004, which is less than 1%. Since p-value is very small, we reject the null hypothesis.